Hello guys, welcome back to another video. I just want to welcome some of my new followers from my school. Shout out to you guys. The law of cosine states that in a triangle, the length of the opposite side of this angle squared equals to the length of the adjacent side squared plus the other adjacent side squared minus 2 times the first adjacent side times the second adjacent side times the cosine of that angle. This formula seems like it just came out of thin air, but I'll explain this in the next video, so stay tuned. So in this video, I want you guys to see how law of cosines can be used in a really difficult problem. So yeah, let's get into the problem. Okay, so we have this semicircle with the chords of 6, 6, and 14. We are trying to find the diameter of this semicircle, which is x. If you want to try this problem for yourself, pause the video right now because I'm going to solve it in free. Okay, I'm solving it. So let's label this center and let's draw some radii to the points of these chords. And let's label these sides as radii because they are radii. And we should also label the points so later on we can actually identify the angles. Okay, so first what I see here is that triangle ABO is congruent to this small triangle BCO because they have the congruent sides. So ABO triangle is congruent to BCO triangle because of the side postulate. And from this we can actually point out that AOB is congruent to angle BOC. Okay, so let's label these angles as alpha and alpha. So what do we know about these three angles? Well, as it turns out, they add up to 180, okay? And I like to call these linear triples. And this means that alpha plus angle COD equals 180 degrees. And now we can find angle COD as 180 minus 2 alpha, and we can label it here. Another thing I can realize is that triangle OCD is an isosceles triangle. This is because this side equals to this side, and if two sides are congruent in a triangle, then this is an isosceles triangle. COD is isosceles, and it turns out that angle OCD is equal to angle ODC because they are the angles of the base, and we can find what these angles are. So angle OCD plus angle ODC is equal to 180 minus this angle, 180 minus 2 alpha, and this will leave us with 2 alpha. The sum of the other angles has to equal to 2 alpha. Now we already know that these angles are equal to each other and their sum is 2 alpha. Therefore, each of them will be 2 alpha divided by 2, which is alpha. Okay, now let's clean up things a little bit and leave these 2 alphas intact. By the way, the quadrilateral OBCD is a trapezoid because angle BOC is congruent to angle OCD, which makes them alternate interior angles. This means that BO is parallel to CD, and I don't know what you can do with this, but I'm kind of curious because while I was making this video I actually saw this, so I want some of you guys to actually solve this using the trapezoid if you can, if it's possible. Let's get back to the video. So now we have this alpha and this alpha, and now the law of cosines comes in. So in triangle BOC, this side squared equals to the adjacent side of alpha, which is r squared, plus the other adjacent side, which is r squared again, minus 2 times r times cosine of alpha. Okay, we can simplify this equation. So first we can multiply these two r's so that we can get 2r squared, and then we can make this 6 squared into 36 because 6 squared is 36, and then we can add up these r squareds, and that will give us 2r squared. Okay, that's pretty good. This is the first equation we got. Now in triangle COD, we don't actually identify what 14 squared is, but we actually identify what this r squared is. This is actually a trick. This r squared equals to this 14 squared plus this r squared minus 2 times 14 times r times cosine of alpha. Okay, that's pretty cool. So now we can simplify this more. 14 squared is the same as 196 2 times 14 times r is 28r. And now let's go even further. We see that common r squareds on both sides, so we can actually subtract r squared from both sides, leaving us with 0 equals 296 minus 28r times cosine of alpha. Now we can go even further and subtract both sides by 196. This will leave us with minus 196 equals to minus 28r times cosine of alpha. And now we can actually identify what cosine of alpha is. So cosine of alpha in this equation is minus 196 divided by this minus 28r. And we can simplify this equation, which gives us 7 over r. Now let's underline this a little bit and look at this equation. We can actually plug in this 7 over r in this equation. I said equation twice. I'm really smart. Okay, we plug in this, and we're gonna go in a little bit spooky territory, so I want this to be visualized better. So let's turn this into this. So 36 equals 2r squared minus 2r squared times 7 over r. So let's simplify this a little bit more. So 2r squared times 7 is 14r squared, and 14r squared is going to be in the numerator, and this r squared will be cancelled out by this r in the denominator. So this will leave us with 14r, and we can actually simplify this a little bit more. Do you see the pattern here? So we can subtract both sides by 36, which leaves us with 2 equals 2r squared minus 14r minus 36. And this looks oddly familiar to the quadratic equation. So this is actually a quadratic equation problem. So now let's focus on this, and we can use the quadratic equation to find what both solutions are. Okay, so in the first solution, instead of minus, let's make this a plus, so we can find the first solution. And this will simplify to being 9. Now what happens in the second solution, you may ask? Well, let's figure it out. Let's label this as the first solution, and let's go in the second solution. And instead of plus here, there's a minus. We plug in the same things in the same places, and this will actually give us minus 2. And the length of a side, or any geometrical figure, can't be a negative number, because a length of a thing is an absolute value of a number. Therefore, minus 2 isn't a solution. This is not correct. So the only solution we have is radius equals to 9. Okay, let's delete everything we have. Let's make this a little bit bigger, and let's clean most of the things here. So in this place, in this place, it will be 9, and we can delete most of the things up top. So this is 9, this is 9. So we haven't found x yet, so let's try to find x real quick. X is the diameter of the semicircle, so it will equal to 2r, and we already found r, which is 9, so let's plug in 9, and x will equal to 18. The answer to this problem is 18. X equals 18. And yep, that's pretty much it for this video. In the next video, I will be explaining why law of cosines work. But I think this was a pretty sick problem. If you actually solved it, I'm very proud of you. And you can actually comment down in the below about the trapezoid solution, or any other thing, or any other way you solved it. I will be glad to hear about it, so I'll be waiting for you in the comments. Anyways, I'll see you in the next one. This is bad.